I'm fortunate to be enjoying another beautiful day here in the Pacific Northwest. Just playing around with my camera down here at the Puget Sound and Olympic Mountain Range vantage point. Let's zoom back in. Checking out some of this flat water at a distance. Looks like it's flat over there. So today, I want to have a quick discussion about some conflicting ideas that I've heard and going back and forth with heliocentric enthusiasts, as I'll call them in this video. We're going to be a little nicer today. One of the things that we deal with is, well, I like to point out the idea that we have all these supposed motions going on. I'll go back through these quickly. We have the Earth is spinning 1,032 miles per hour at the equator. We're orbiting around the sun at 67,000 miles per hour. The sun is supposed to be orbiting around the Milky Way galaxy around 450,000 miles per hour. The whole galaxy itself is supposed to be flying through space at a whopping 515,000 miles per hour. Okay, so when I point out all those movements, I like to ask people, why is it that we don't feel any of this motion? Why is the motion absent in all this that we have going on? Shouldn't we be experiencing something, some semblance of movement? But we're not. And I like to point out, and I'll just say, that's because we live on a flat, stationary Earth. That's what it is. The Earth is flat. And they'll rebut that statement with, well, no. The thing is, the atmosphere protects us from all that motion. That's why we don't feel it. Also, we're out in space, so there's relativity. There's no actual up or down. You know, gravity pulls everything towards the center of the Earth. There's no up or down. It's relativity. So that's why we don't detect any motion. Okay, let's say that's the way it is. All right, that's fine. That's fine. Relativity is what keeps us from sensing any motion. All right, so another thing that we deal with is their argument of the Coriolis effect. They like to point that out as a proof that the Earth is a spinning ball. The Coriolis effect. And what happens with that is they like to say that, well, sniper bullets or snipers, they have to compensate for the Earth's spin while before they take their shot. There was actually a video that I was watching. Neil deGrasse Tyson was talking to a gullible young lady. I'm sorry if you actually see this girl, but he sat here and he said he was at a football game or watching a football game, and he whipped out his little notepad, did a quick little equation, did some quick little math. She's sitting there all bright-eyed. Wow. He said, and the reason why that field goal went in was because the Earth spin tipped it in there. And had the Earth not been spinning, they would have lost that game. And she's just like, wow. Her mind was blown by bull crap. And that's the Coriolis effect that he was supposedly speaking of. So, my question at this point, in dealing with relativity, which shields us from detection of any of this motion, and the Coriolis effect, which also, I don't know, the antithesis of that is something that we use to compensate for the Earth's spin, as snipers do, right? Those are two conflicting ideas, or what I like to call a heliocentric contradiction. Those are two conflicting ideas. They don't balance out. It doesn't hold any water. The idea falls flat. So there's that one, and there's another one that I like to point out. You know, I'll have these discussions, but I always go back to ground level. The basic understanding that the Earth is flat is that bodies of water do not curve. And yet, when I articulate this to people, they will come back and say, well, there was a time I was off at the shore and I saw a boat go over the curvature. They see a boat going over the curvature from ground level. Okay, let's say that actually happened. Okay, you saw a boat go over the curvature. So, myself, I fly quite often. Not in a plane. So, I fly often, so I'll point out to people, look, I'm usually one or two flights out, I'll get a window seat. And as I look out of the window, I never see any curvature. Never. And I tell them they don't either, but they swear they see the curvature. But when I say that everything looks flat from where I am, they say, well, you're not, that's because you're not high enough to see the curvature. Well, hold up. You just sat here and said that from ground level, you can see ships, boats go over the horizon of the water going over the curvature from ground level. Yet when I'm in the air, 35,000 feet, you're telling me that I'm not up high enough to see any curvature. So which one is it? That's another contradiction. See what's going on here? What we're going to do from here, you heliocentric enthusiasts, we're going to start picking apart your science. We're going to break that down. We're going to throw it right back at you. Which one is it? Coriolis effect or relativity? Did you see the boat go over the curvature? Or are you telling me that I'm not up high enough to see curvature? Because you can't have it both ways. This is what we're going to do. We're going to break you down. We're going to break down all your little arguments, and we're going to show you exactly how ridiculous this whole idea is. The Earth is flat. We are not on a spinning ball flying through space at ridiculous speeds. That's not happening. So that's what we got. That's what we're coming with. Get ready. We're coming for you. I'm out.